Travtek, short for Travel Technology, was one of the first of many operational field test projects to develop and test new concepts for Intelligent Transportation Systems, ITS. The Department of Transportation's ITS program is the product of the Intermodal Surface Transportation Efficiency Act, signed by Congress in 1991. This initiative invoked new ways of thinking and accomplishing transportation goals by means of partnerships involving the public and private sectors. Major ITS program goals are to apply our nation's vast technological resources for improving safety on the nation's surface transportation system, improving travel without harming the environment, providing convenient travel for all Americans, increasing transportation system efficiency, and boosting productivity. To see how one element of our nation's intelligent transportation systems may operate in the not-too-distant future, and to more clearly present the scope and complexity of ITS operational tests, we present a brief report on the evaluation of Travtek, a model ITS operational field test. Consistent with the theme of Congress, Travtek was developed by a public-private partnership. The public sector, represented by the Federal Highway Administration, Florida's Department of Transportation, and the City of Orlando. The private sector, represented by the American Automobile Association and General Motors. Beginning in June 1989, these partners came together to apply user-friendly human factors design principles in the building of a driver information system that would address partner-developed goals consistent with the ITS program. For example, the Travtek partners wanted to build a system that would be safe and easy to use, benefit both non-Travtek and Travtek drivers, in saving time, helping to avoid congestion, and having a positive impact on the local area. Provide data for assessing driver, system, and traffic network performance. And provide the opportunity to assess drivers' feature preferences and willingness to pay. The partners organized into three basic committees. The steering committee provided executive guidance to the program manager, and the technical and evaluation working groups worked together to build, test, and evaluate the system. The result was Travtek, a system that used computer and communications technologies to provide drivers with trip planning, navigation, and traffic information through voice messages and graphic displays to help get them to their destination safely and efficiently. There were three components of the Travtek system: the fleet of Travtek cars, the Traffic Management Center, and the Travtek Information and Services Center. Each of the Travtek system components was designed to support Travtek operations and collect evaluation data simultaneously. For example, the automatic recording of data in each vehicle created a valuable and extensive database of drivers' button presses and choices, vehicle speeds, positions, headings, and communications with the Traffic Management Center. The Travtek fleet consisted of 100 specially equipped 1992 Oldsmobiles. These cars were capable of providing drivers information about local services and attractions, as well as personalized navigational maps and route planning. To answer important system design and market research questions regarding the value of alternative features, GM designed the Travtek cars to have three selectable levels of functional capability, represented by the Services, Navigation, and Navigation Plus configurations. In addition to providing display information about local services and attractions, the services configuration was a baseline or control condition for evaluating the performance of alternate route guidance and navigation configurations. For basic navigation, services drivers were provided a pre-drive map display that showed the position of the selected attraction relative to the current position of the Travtek car. The navigation configuration provided all the features just described with the addition of route planning. and navigation features that showed and told the driver where the Travtek car was located.
Approaching Orpington Street, headed south.
And route guidance by means of displays and voice messages that provided turning information.
Turn left onto University Boulevard.
While all Travtek cars reported their positions and travel times to the Traffic Management Center, for this configuration, the in-vehicle route planning feature used a basic set of travel times installed into each car to determine the quickest route. The Navigation Plus configuration provided all the features of the services and the navigation configurations and added real-time traffic information broadcast from the Traffic Management Center. This feature allowed each car's navigation system to use this information to select routes or reroute based upon real-time traffic conditions. With these three configurations, along with automatic recording of driver button presses and system performance, the partners created an unprecedented capability for quantifying the value of in-vehicle route planning, navigation, and guidance alternatives. By comparing the performance of drivers with the services configured cars and those with the navigation configured cars, we can address the question, do route planning, navigation, and guidance systems improve mobility? And by comparing performance of drivers with the navigation configured cars and those with the Navigation Plus configured cars, we can address the question, does adding real-time traffic information increase the value of in-vehicle route planning and guidance by helping to avoid congestion? The second major component of the Travtek system was the Orlando Traffic Management Center. This center maintained two-way data communications with the cars. It recorded travel time information transmitted from the Travtek cars driving in the Orlando network and integrated it with information collected from traffic sensors and other traffic information sources. This center then transmitted travel time updates for use by the Navigation Plus configured Travtek cars, while retaining a record of all transmissions for later evaluations.
Thank you for calling AAA Travtek. Can I help you?
The third component of the Travtek system, the Travtek Information and Services Center, provided 24-hour cellular phone help desk services to Travtek drivers to answer drivers' questions, provide emergency road service, and record important data for evaluating problems encountered by those using the system. Travtek's operational test was conducted in the Orlando, Florida metropolitan area for a period of 12 months. Consistent with the goals of the ITS program, the Travtek test addressed these 8 basic questions. Did the Travtek system work? Was Travtek safe? Did drivers save time and avoid congestion? Will drivers use the system? What guidance system was most effective, the moving map display or the turn-by-turn display? What was the value of augmenting displays with voice messages? Could Travtek benefit travelers who don't have the Travtek system? Will people be willing to pay for Travtek features? Using these questions as their foundation, the Evaluation Working Group designed a comprehensive evaluation program. This program consisted of separate yet interrelated studies that produced 4 different types of data. Approximately 4,000 drivers drove the 100 Travtek cars and participated in either the field studies or field experiments. Demographic data about types of drivers were correlated with the driver's performance and preferences. There were 2 field studies, the rental user study and the local user study. The purpose of these studies was to see how these different groups of drivers would use the car on their own. These drivers were unconstrained in the routes they chose or their methods of getting to their destinations. The rental user study included over 3,900 volunteer drivers who were recruited through AAA and who rented their cars through Avis. These drivers were generally unfamiliar with the Orlando area. The local user study provided cars to 53 high-mileage local drivers who used the cars as they would their own. These drivers were generally familiar with the Orlando area. 3 controlled experiments were also included in the Travtek evaluation. The purpose of these studies was to evaluate specific Travtek features and issues under well-controlled conditions and with observers present in the car. The yoked driver study focused on differences among Travtek car configurations as they affected travel time and navigational waste during peak traffic conditions. The Orlando Test Network study compared traditional routing methods, such as using a paper map, to alternate methods. Voice guidance was tested on its own and as a supplement to the route map and turn-by-turn guidance displays.
Bear right onto the ramp to I-4 freeway west.
The camera car study was designed to examine in-vehicle safety and driver performance issues associated with the use of navigation and route guidance displays, and how driver age and experience might relate to these issues. The debriefing and questionnaire studies provided drivers an opportunity to describe their immediate impressions about Travtek, as well as their overall impressions about Travtek features, how they drove with the Travtek system, and their willingness to pay for Travtek features. The traffic modeling study used the integration model to predict network-wide travel time benefits, fuel consumption and emission statistics, network safety indicators, and how different levels of market penetration of Travtek-like vehicles would affect these situations. The safety study combined the camera car and other study results to see whether drivers drove more or less safely with Travtek, and if there would be a decrease or increase in total number of network-wide collisions if a large fraction of vehicles were equipped with Travtek-like systems. The architecture study examined the overall reliability of the Travtek system, including computer hardware and software, travel time prediction accuracy, and sufficiency of network communications coverage. Turning now to results and the answers to the 8 previously discussed evaluation questions. Did the Travtek system work? Travtek technologies functioned at an acceptable level and driver ratings were high. The Travtek system was very reliable. All subsystems performed well throughout the field test. When a sample of communications from Travtek vehicles was mapped, the Travtek test area appeared to be well covered. The system did not show any operational characteristics that limited its performance. Was Travtek safe? There was no evidence from any studies that the Travtek system created a safety hazard. Drivers in the field studies gave Travtek positive safety ratings, and the number of close calls reported for those with the system was no different than for those without the system. In the camera car study, when complex map displays were used, the study of close calls showed the voice display to provide a safety benefit by reducing the amount of time needed to study the map display.
Ahead, next turn, in 1 4/10 miles.
Although the study showed that drivers 65 years of age or over did not perform as well as others, these same older drivers benefited the most by Travtek turn-by-turn guidance, especially when voice guidance was used. For example, Travtek compared to non-Travtek control conditions reduced older drivers' lane deviations. Did drivers save time and avoid congestion? All of the controlled field experiments using drivers unfamiliar with the area demonstrated a travel time benefit from use of the Travtek system for route planning and route guidance. The largest benefit was in trip planning. The field experiments showed that the Travtek system saved time for drivers who were not familiar with the area. Drivers using Travtek took less than 2 minutes to plan a 10-mile trip, compared to 10 minutes for those without Travtek. Even high-mileage local drivers saved trip planning time. One local driver did not want to give up the car, claiming Travtek's automatic route planning was responsible for a 40% increase in sales during the 8 weeks the system was used. En route travel time savings were also significant. The field experiment showed that Travtek provided unfamiliar drivers with en route savings of as much as 5 minutes in a 25-minute trip. Trends also showed that Travtek helped to avoid congestion. Those driving the Navigation Plus configured cars were observed to encounter less congestion than those whose cars did not receive real-time information. Will drivers use Travtek? The majority of participants in all studies gave favorable responses about Travtek. Overall, participants rated Travtek as useful and easy to use. Field studies revealed that rental drivers of the services configuration used services features on 37% of the trips taken, while renters and local drivers who had cars with the navigation and routing features used these features for approximately 80% of their trips. How effective was voice guidance compared to moving map and turn-by-turn guidance displays? In general, turn-by-turn guidance information, whether provided by voice,
Turn left onto University Boulevard,
computer-generated visual displays, or a simple list of directions, like those commonly provided by rental car agencies, provided the most efficient and usable means of navigation. The moving map display without voice guidance required more visual attention and had more navigational errors than either the moving map display, supplemented with voice, or the turn-by-turn display, with or without voice. However, when either Travtek route guidance display was used, with or without voice guidance, it still resulted in significantly faster en route travel times over non-guided cars. Could Travtek benefit travelers who did not have Travtek? Results of the modeling study, although based on a limited data set, were encouraging. Modeling estimates showed that a deployed Travtek-like system would have an overall network benefit to both Travtek and non-Travtek users. Travtek simulations showed reductions in wrong turns, trip duration and trip lengths, fuel consumption, and vehicle emissions. The traffic modeling study also showed that as more Travtek-equipped cars are on the road, there would be improved information on arterial street traffic congestion. Such information would have made a major improvement in the overall performance of the Travtek-equipped cars and the overall traffic network. Will people be willing to pay for Travtek features? Over half of the participants indicated they would be willing to pay $900 or more for a Travtek-like system. In summary, Travtek was successful in all respects, meeting all objectives. It demonstrated the success that can be achieved through partnerships between public and private sectors. It demonstrated the feasibility of the concept of intelligent transportation systems, and it showed that a sophisticated driver information and traffic management system could be given to the public, and it would work reliably and safely. When given the system, the public chose to use it and indicated they would be willing to pay the same amount as a high-end stereo option on a new car. With Travtek, drivers did save time in planning trips and driving to their destinations. Travtek showed that people who did not have Travtek could benefit by Travtek's ability to ease congestion over the span of a city's entire traffic network. Travtek's close coordination among designers and evaluators from the beginning of concept development through system design and build to collection and analysis of the last piece of field data serves as a model for the conduct of future ITS operational tests.